question up to number 6 last week. So we continue our tutorial 2 from question number 7 now. Today we try to discuss 3 questions, 7, 8, 9 only. Okay, here we go, question number 7.
Number 7. You are given the following. 100 people entered a mortality study at time 0. So we have a truncation value at time 0 where the frequency is 100. Number 2, at time 6, 15 people live. That means this is our censored value at time 6 where the frequency is 15. Number 3, 10 deaths occur before time 6. This means that this is our uncensored value, that is the x before time 6, which is greater or equals to 1 because the time 0 is already occupied by the truncation value. And the frequency, which is 10. So this one also can be written as the uncensored value is from 1 to 5. Number 4, 3 deaths occur between time 6 and time 10. So this is referred to the uncensored value, that is between 6 and 10. So where the frequency, which is 3. So this one also can be written as the x for the uncensored value taking from 7 to 10. So based on this information here, we need to calculate what is the survival at 10 based on the product limit estimate that is under the Kaplan measure.
Now, class, so you have to take note that all the x value is there's no overlapping. You can see, sorry, I'm talking about the data. The data is including the truncation, the censored value, and also uncensored value. You can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? The data is from 0 to 10. That's occupied by the truncation, uncensored value, and also the censored value. There's no overlapping, data, no overlapping base. Okay, so as I said, that 0 is from truncation, that 1 to 5 occupied by the uncensored, 6 occupied by the censored value, and 7 to 10 by the uncensored value again. Okay, so you have to know how to form the data. Okay, so our aim is to estimate this survival at 10 by taking this production limit. There's a Kaplan measure. Okay, so we use we have to consider the initial enter observation. Okay, so we have to use a second method to solve this problem. Okay, so here we go.
Solution for number 7. Let x be the random variable represent the mortality data for xi. Then we have this chart. So we need to place all the uncensored value, censored value, and also the truncation value into this chart. So from here, we can get all the data. So we place our I into these 4 groups. So when time is 0, the first value we have is the truncation value at 0. That is, we have 100 of 0. And next will be the time 1 to 5, we have the uncensored value. That is from 1 to 5. So the frequency is 10. And next will be the censored value at time 6. We have 15. And the last will be the uncensored value for the 7 to 10. And the frequency of this depth, which is 3. Based on the uncensored value here, we are looking for these two rows. So now we try to calculate the conditional frequency for the X.
Okay, class, before we go further, do not confuse about the I and XI. I is just a reference number. Okay, just coincident is the same value. Okay, this data actually is the same value as I. Okay, like you can see the interval for the I, from this is 1 to 5, the uncensored value also 1 to 5. Okay, when the I is from 7 to 10, the uncensored value also 7 to 10. Okay, so do not worry about this. Okay, just a reference number for the I.
7 to 10 cannot write 6.
Can.
Cannot.
Sorry?
The 7 to 10 cannot write 6 to 10.
No, you must write 7 to 10. 6 is occupied, I told you. There's no overlapping. 6 is only for the censored value. Okay, it's not for the 6 to 10. 6 is only occupied by the uncensored. Sorry, by the censored. Okay, 6 is not belongs to the uncensored. This you must be careful. If you place wrongly, then the whole thing all wrong. Okay, so now we try to calculate the conditional frequency for this uncensored, censored, and truncated value. Okay,
So if we choose this X value, so how many X value which is strictly less than the XI? So we have nothing. There's no X value which is less than this group. And if I choose my X value from this group, so how many X value is less than this group? I have 10 of this group, which is less than this group. So now we go to the censored value for the 6. So look at this condition for the U, which is really less than the XI. So if I choose this group, how many U's value which is strictly less than this group? So I have nothing. No values from the U which is less than this group. So I will have 0. Place into the correct row. And next I choose this group. So how many U's value which is less than this group? I have 15 of 6 which is less than this group. So it's 15. And last, we try to look for the condition of this truncation value, which is slightly less than the XI. How many these value, which is less than this group? I have 100 of 0, which is less than this group. So this is 100. Okay, we place on this row. And next, I will choose this group. How many these value, which is less than this group? Again, I have 100. So next, I'm going to calculate what is the R value by taking this minus this and minus this. So I will have 100. 100 minus 15 minus 10, I have 75. So our aim for this question is to find the survival at 10 by taking this Kaplan measure.
Okay, class. Again, before go further, I highlight here, place the value according to the row. Okay, you only can place all the frequency, the conditional frequency, based on this arrow I put here, because this is only have the uncensored value. Okay, this cell and this cell are empty, right? These two cells are empty, so we don't have any R value. Okay, so the R value is only based on the uncensored value. Therefore, the condition frequency for the X, for the U, for the D it will calculate. Do not based on, because now I'm using one table only. Okay. And one more I want to highlight with you, class. Please pay attention because your friend asked me last week. Now, by actually we use other method, class. That is the other condition x greater or equal to xi. You also can get the answer, provided you have condition. Provided all your frequency is complete. Otherwise, you may not get the answer. Okay. What I mean is, other than 7 to 10, if you still have, sorry, after 7 and 10, there's no more frequency at all. Let's say, assume that this is the entire frequency, then you can use the first method to calculate. Otherwise, you may not get the answer, or you may get the wrong answer. To be safe, if you have the initial observation, then you better use second method. Okay. Example 8, you can use both methods because example is the entire frequency. There's no more frequency after the last observation. Okay, so this is quite risky. If you have this initial observation, you use the first method, it's quite risky. Okay, I hope you get it. Okay, now we can calculate this survival at 10. Carry on.
So, since 10 is inside the last group, therefore, we try to consider the whole R set value. So, therefore, this survival at 10, which is equals to 1 minus 10 over 100 times 1 minus 3 divided by 75. So we will have 108 divided by 125.
Okay, so this is clear. Once you have the R value, then you can calculate either is Kaplan-Meier or Nelson-Allen. You can solve the problem. The most important is you must have the R value. Okay, I think this is clear. Except how you set up. Okay, I would say the setup technique is important. Calculation, I believe you know how to calculate. Only the setup technique. Okay. Read question carefully. Do not overlap the data. Okay. So I move to next question number 8 now. Okay, here we go.
Number 8. A mortality study involves a group of n individuals. That means this is our truncation value entered at the beginning. So we name as naught. One individual appears dies at time x1 and x2. So this is our uncensored value for the x. No withdrawal occurs before time x2. So before time x2 here, there's no censored value. You calculate the Nelson-Allen estimator of the cumulative hazard function at time x2, which is 0.1144. Determine the product limit estimate of survival at x2. So this is our aim, to find this survival at x2 by using the Kaplan-Meier method. To solve this problem, we have to find the value of n. Solution for number 8. Let x be...
Okay, hold for a while. I think I got some message from who? Okay, not important.
Solution for number 8. Let X be the random variable representing the mortality data. We need to place all the data in this chart. So at the beginning, we have X0. The frequency is n. Next, we have the uncensored value for x1 and x2. The number of observations are 1. So before x2, we do not have any censored value. So let's calculate the conditional frequency of x and d as well. So the first one, we try this x, which is slightly less than the xi. So if my x1, I choose this. So how many x value which is less than x1? So I do not have any value which is less than x1. If I choose my x2, so how many x value which is less than x2? I have only got one x1 value which is less than x2. And next we go to the condition frequency for the truncation value. So again,
Okay, hold on, class. I think no sound. Sure, no sound.
so we try to rearrange this.
Are there? My phone got sound.
They didn't want to buy the guy that commented.
Okay, tell me, the student, online student, can you tell me? I think have no problem. Someone say no sound. Jian, can you double check your mic? Or maybe just now don't have, now have, right? No, I didn't do anything. Okay, I repeat again from the middle section there. Okay.
So I place here. So if I choose x2, again also I have an n of x0 which is less than x2. So I will have n again. So the r's value, I will take this minus this. So I will have n and n minus 1. Next, given that the qubit hazard at x2, which is 0.1144 under Nelson-Allen. So therefore, this will be equal to 1 over n plus 1 over n minus 1. So obviously our n cannot be 0 and also cannot be 1. So in other words, our n must be always certainly more than 1. So we try to rearrange this into the fraction number. So this becomes 143 divided by 1250, and this will give me 2n minus 1 divided by n times n minus 1. So rearrange this, I will have a quadratic equation which is 143 n squared minus 2643 n plus 1250, which is equal to 0. And so therefore our n is equals to 2643 plus minus 2643 squared minus 4 times 143 and times 1250 and divided by 2 times 143. So we will have 17.99 or 0.4857. Since our n must be integer and also more than 1, therefore the n is about 18. So our aim now is to find what is the survival at x2 by picking the Kaplan-Meier. So x2 is false on this group, so therefore we have to consider these two R value. So by taking the Kaplan-Meier, so this survival at x2, which is equals to 1 minus 1 divided by n times 1 minus 1 divided by n minus 1. So substitute the n inside here, we will have 1 minus 1 over 18, 1 minus 1 over 17, and this will give 8 over 9.
Okay, class, for this problem, quite long. Our aim is to solve, to find this survival at x2, the probability here by this Kaplan-Meier, so the answer is 8 over 9. Our aim is to find what is the 18 first. What is the n value, okay? Now, here the calculation, I believe you have no problem. I just worried you do know how to set up. Okay, once you know how to set up, then the rest no problem. Okay, if you look at the question here, we have two uncensored value, the dead value. Okay, this is a mortality study involve n individual. That is at the beginning we have n individual, and we assume it's an x0. Since the question is given x1, x2, okay, that is the data dies, okay, at times x1 and x2. So at the beginning, we just assume that it's the x0 for the data. That is for the truncation. You can put other alphabet if you want. Okay, so here I just take x0. Okay, you can put d here, no problem, or d not available. Okay, and we don't have any withdrawal. Okay, that means all the u are 0. Okay, so it's very clear that this data in this our chart here, we only have 3 data. Can you see? Before I place the frequency, we have 3 data: x0, x1, x2 only. You must know what is your data, what is your frequency here. Do not mix up. You must know what is your I also. I is a reference number. Some of you don't like, or you don't know how to use them, you don't put. I is just a reference number, nothing to do with our calculation. Okay, so after that you must know how to, of course, frequency no problem, because the question said is only one for the death for each. Okay, but this one we have n. So the rest, once you know how to set up, then you must know how to calculate the collision frequency. And after that, of course, no problem for the R. Right? So once you have the R value, then you just follow the instruction. If they say Kaplan-Meier, you go ahead. If they say it's a Nelson-Allen, you go ahead. Okay, that one should be no problem. If you know how to set up, but you still don't know how to calculate with the Nelson-Allen or Kaplan-Meier, then you have to go back, okay, do more revision, how to use the formula. Okay, so this problem should be, you have no problem on this. Okay, our n is about 18 because cannot be 0 or 1. Okay, so it's about 18. So we have done the question number 8. So give me a few minutes. I want to take your attendance.